Hey guys, welcome to the project Futura, which is the project to teach you how to make a relatively advanced Micromouse work and be competitive in the competition. So firstly, this is the mouse that I made in order to be the teaching tool for you guys to apply your learning skills on the mouse. A brief introduction. As you can see, all the items are listed on here, and the first term is to help the experienced student, which are you guys, because since you guys are did some kind of similar thing before, have experience in doing the PCB and constructing circuits and program on Arduino at least. So you guys are selected for this reason. That's why you have some basic knowledge in order to start at a relatively higher level, in order to manipulate the mouse. Second, because the mouse I'm making is capable to make a curved turn search, that's why what makes difference with this kind of like cheap and low-end Micromouse. Well, this is cheap as well. So this is a two-wheel Micromouse, and it's really cheap. It's only costs $150 for everything, including batteries, chargers, Bluetooth adapter, FTDI board, and the programmer, and the box. So as I said, the high resolution encoder is the key, because with low resolution encoder, encoder is the device to keep track of the angle of the motor rotation. Right? We can literally convert that to the distance moved by the mouse. And if we have higher enough encoder resolution, we can check the encoder resolution very frequently in a really short time period. Instead, the value you read at the speed. That's how we keep track of speed at the feedback system. That's how we make the closed loop controlling system. That's what which guys learned in E141. Some of you are taking it out. Okay, so the other good advantage to participate in this program is, since we're making this a reliable working tool, testing tools, as long as you're taking the lectures and learn from the other lecturers, Jeremy and David, you'll be able to apply the code immediately on this tool without having any troubles to worry about if there's any potential hardware issues. So if your code is right, it will work. And however, this is a teaching tool. As what we agreed, we will not allow you to carry this mouse to any kind of competitions. So as a result, you will design your own mouse and submit your design by the end of this quarter. And of course, the reason I make this kit mouse is I kind of figure out make a solution for motor encoder wheel combo. It's kind of like this kind of thing they sell on the website, except mine is like easier to construct and cheaper. And you are allowed to use the motor encoder board wheel this combo on your own mouse. And the spec for those the holes where they are will be given. And what we're going to do by yourself is, based on the limitation of this mount, you decide the outline of your PCB and place all the parts. And of course, you choose yourself. And we will help you. And week 6, we will have the design review to help you. You guys should show us your brief design, including some really brief schematics. So we will give you advice if it's correct or what should be improved. Then for the rest of the quarter, you finish your PCB design. Okay. Okay, this is spec for the mouse. As you can see, this mouse is surprisingly light. The weight is only under 75 grams, which is like much lighter than the 4-wheel Micromouse I have. One reason because the 2-wheel and the less wheel. The other reason is because I use a MakerBot to print out those 3D printing components, which is like the center is like kind of hollow and empty. That's why it makes light. remember the Micromouse always lighter the better. So these are 3 dimension. This is the wheel with battery, and so the wheel and this spacer are printed by 3D printer. That's it. And the M series STM32 F405, which is the one I use for my 4-wheel Micromouse, which is also the most popular microcontroller being used for the Micromouse society. And the model is really easy to get. It's probably 1 to 10 gear ratio high power model. It comes with a bracket, so that's why I can easily mount this thing on the board just use screw elements. And the encoder is from AMS. Its model number is AS5304, and Jeremy will give a brief introduction about the encoder. And the battery for this one is 120 mAh, 25C discharge rate, 2 serial, 1 parallel battery, which means you have 2 batteries serial, each one 3 point volts, 2 of them gives 7.4 volts serial. And remember, the battery we're giving doesn't have a protected circuit in order to give as high as possible discharge rate. That's why we have such a high discharge rate here. So when you program your mouse, you should keep track of the remaining voltage. Otherwise, as long as you over discharge your mouse to make your over discharge your battery to make your battery level lower than certain level, it will permanently reduce the battery lifetime for the battery. So it's bad. Okay, these are H-bridge level shifter. It's like sensor pair. This is infrared emitter. This is infrared receiver. So it makes a pair. So the emitter sending out the light bound back from an object. Receive pickup and receive. They use ADC. This is Gyro. It's pretty cheap and a popular solution in the Micromouse society. It's really easy to get on the for the user interface, there are 2 buttons here, so you can program the behavior of the buttons to achieve a lot of functionalities. Of course, 11 LEDs. There are 6 LEDs here, for kind of bar LED bars, and there are 1 LED here, 1 LED here, 1 LED here, 1 LED here, to help you, do it do debugging, doing the turning. For instance, if you turn off, you can just turn these 2 LED on, So, and and one LED matrix, LED dot matrix display. It's a full character alphanumeric display, and display a lot of information, of course, because it display literally display letters. Remember, there's the buzzer. The buzzer can beep because sometimes when your mouse moves really fast, you can't even look at the LED or screen at all. So I can probably just hear it. So if detecting a pull, a opening from the wall to the wall, right? If you beep, whenever you detect it, you beep it. It means okay, we did detect the pulse. That's how we use that for debugging. Next step. Here's a demo. Your demo what's the best I can achieve for the Micromouse. The search at a 0.0 meter per second search speed. So reach the center, come back, accelerate on the straight path that we searched before. So this is 0. And come back. Well, of course, as long as your mouse is capable to as long as your mouse is capable to do the way smooth turn search like that way, which means your mouse is definitely capable to do diagonal turn, which is different kind of turns, with different angles, different radius. Because I didn't have time to tune the parameters. That's why I went that way. And also, you saw that's what I also expect you to do to behave at the end of this quarter, except I was running at 0.7 meter per second. You might need to run at least 0.5 meter per second, but it should be curved turn. So that's why as long as you follow the course, you'll be able to do that. It's not that hard. Okay, how's it made? So first step in design PCB, is Of course, I just schematic for it first, and this out layer of PCB, and the gap here is literally limited by the model I'm designing. So when you're designing your own mouse, this area is pretty much limited, and the holes for encoders are limited. The holes for the motor screws are limited. So you can't put parts like everywhere, here and here, except for these two areas. So you have sufficient amount of space. Seem like you have a lot of space, right? So the next part is because we have a lot of mouse, like 5 mice here. So we have prepared an amount of parts for 5 mice. So we soldered all the SMD components together. These are encoder boards. These are Bluetooth adapters. These are battery chargers. These are batteries. Battery is the hardest part to do because it's just we have to rip off the original one and solder the headers by ourselves. So yeah, we literally spent a lot of time with Jeremy and David. So we should thank them for their dedication. So you guys should cherish this because we don't want any of you to damage it. So after we finish the assembly of the mouse, we just make tests. So I made a test code. I literally test all the components one by one. Because due to process, actually, some of the mouse are not working for some certain parts, and we couldn't figure out which part was wrong, so we just soldered brand new mouse. So, in order to keep mouse safe and well protected, that's why I bought the container and applied the foams inside the mouse as a buffer. Because we want you guys keep safe, and we're expecting any of you guys, have the time or, or motivated to teach, any other student in the future to continue to passing on our knowledge of advanced Micromouse. All right, so let's have the part to Jeremy and David to start our first lecture today.
So today we'll pretty much just be going over how to load code onto your mouse, basically, and we've sort of built like a software suite for you guys. Like it has all the basic functions to turn on the motors and turn on the LEDs and turn on the matrix display and display something useful. And so we'll just go over all those functions that we've written for you guys, and we'll give you all that code. So we'll be using the Keel IDE. How can I see it on here too?
Yeah, I try just like escape, click escape, because there's only screen here. There's only display on this one.
Do you have the Keel IDE?
Yeah.
So that's a symbol for Keel UVision 4.
Keel Microvision 4.
So
Takes a while to load.
So yeah, this is what it looks like. Over here you got like all your files. This is Green's code. It's not the one you're going to be using. But yeah, you have all your files here. Up across the top you have another list of files. If you just click on it over here, it appears right here, and you can just edit it. Okay. So I just sort of like wrote a reference for you guys, like how to install this stuff. So you have, we'll give you this file, and you have to install these things, and then you open the project with this file. And so when you want to add new files, first what you do is you click on this folder over here, either this folder or this folder, user lib source. for userlib ink. And then you can just navigate to your file and it'll add it.
Yeah, don't worry, if the information is like too much, we just print it here so that in the future, if you guys are lost or anything, you guys can come back to
this
this.
is just like sort of a reference.
Don't like take it too seriously. We'll go over all these things. You guys get more questions.
Okay, and so to download your code to the mouse, you have right here. You have like this little female header, and can you use the program? And then you'll have access to these. We don't have one for you guys yet.
Can you go back to the previous page about the big picture of the mouse? So you can. Yeah.
Sure.
I think very first one. This one?
Yeah. So these three holes, TMS, TCK, and ground, those are the three holes that you use to connect to the program. So you just connect it. You got to make sure it's oriented the right way.
Turn power on.
Yeah, you got to turn the power on. You have to have batteries in, and then you can load your code in Gyro. So the way you load your code, you go to Flash and then download.
Yeah, there's a download button there as well.
So here's one of the functions that we have for you guys ready to go. It's called read sensor. Basically, all it does is it goes through each sensor. It turns them on one at a time because the way these sensors work is they emit some IR light,
Some infrared rays.
infrared light, and then it measures the intensity of the infrared light. So if the wall is closer, you're going to get a higher intensity. But that also means that they can interfere with each other. So if you have two on at the same time, you could increase the reading of the intensity. So what you want to do is you want to turn them on one at a time, and give it some time for it to like turn on, and then give it some time to turn off before you turn the next one on, and so forth. So what this does is it kind of takes a long time compared to some of the other functions because you have to turn each one on and then wait for a while before you turn it off again and check the next one.
Because the receiver takes a while to get fully charged until the maximum level to read. That's why the time you have to take. Also, after finish reading, you have to take a while for the other sensor to totally discharge back to zero level. So you have no interference.
And it's really important to like be aware of how long things are taking because we're eventually going to put this function into a 1 millisecond interrupt, and which means that you have to run like a lot of code within 1 millisecond. And so you sort of have to know how long these things are taking because if it takes longer than 1 millisecond, then you're not going to have enough time to do all the other things that you need to do. And so basically it reads each sensor, it puts the values into these global variables, and then you can just access these after you've called it.
You shift plus F5.
Okay. And then, so you also have a gyro on this thing. Gyro is basically a device that reads angular velocity. So it's sort of like, you can get away without using the gyro because we have these really high resolution encoders, and if you compare the two encoder values, you can sort of get the angular velocity too. Like you can sort of get the same thing, but it's just an extra backup of how you can get like some more information. And when you combine these two sensors, then you get like a better reading of like what your mouse is actually doing.
Yeah,
So
let me add to that. So in layman's term, what a gyro does is, if the mouse is physically moving, some value will be increasing. So just to give you a rough estimate, if the mouse is like right there and it turns 90 degrees, the value that the gyro gives you is around 18,000. That tells you like, well, it's approximate thing you have to test out. So that's just layman's term.
Well, it tells you the angular velocity. So like,
And then,
you're saying like, so you take the integral of the velocity, which basically means you read the gyro a bunch of times, and then you just add up all the values. That's taking the integral.
And that's what's placed into this angle, the variable.
Right.
That's what I want to do.
So a speed is your angular velocity, and angle is the integral of this, which is your current angle. Read voltmeter. You also want to be really careful with these batteries. They're really small, and they discharge pretty quickly, and you can like damage them if you let it drain out all the way. So you want to always check to make sure that the voltage of these isn't getting too low. If it gets too low, then you got to charge it, switch out your battery. Yeah.
Can you programmatically shut off the mouse? Or shut off current draw?
Well, you can turn off the motors and
Just use LED on screen.
Yeah.
Display something tells you the battery is low.
Okay, that's what we do. Yeah. So yeah, when you call this function, it writes it into this variable called voltage, and you can just, you call this function, then you read the voltage. So your encoders is sort of like the main, like Green was saying, it's like really important for this mouse, because we want you guys to be able to do curve turns, and it's kind of not really possible to do with the low resolution encoder, like the encoders that these motors normally come with. I think it's like 48 per revolution or something like that.
Yeah, right.
48 per revolution. This one has 3,520 per revolution.
It's still low. It's still low.
It's much higher than your average encoder. So yeah, basically, one of the reasons that we recommend you use the STM32 microcontroller instead of like a Teensy or a Arduino is that STM32 has built-in encoder hardware encoder like counter. So with an Arduino, you're normally gonna have like a software interrupt happen whenever an encoder tick happens, and since this is so fast, there's no way it's ever gonna be able to like keep up with this encoder. So the STM32, it's like all built into the hardware, so when the encoder ticks, it doesn't affect your program at all. And so that's why you need to use like a more advanced microcontroller than the Teensy. And so these ones aren't really like the other ones. The other functions we had, they basically write the value into a global variable, and then you can read that global variable. These ones just return an int32. So you just say some variable equals get left encoder count, and that's your left encoder count. So we also have user interface. We've got a buzzer here. That's this black round thing. It makes a sound. You can call it with this short beep function. You give it a duration, which is in milliseconds, and a frequency, which is in hertz, and then it'll just make a sound. So it's useful for debugging. You also have the matrix display, which Green talked about a little bit. It's got 4 characters, and you can call it with this function, display matrix, and you give it a 4-character string.
You can turn it on. You have the battery turn on. I think I have code for other mouse.
Just load your code onto it.
It's already there.
Oh, it's already in this mouse?
Yeah, all of them. Turn it on. Okay, at the beginning. So at the very beginning, turn it on. You guys should see. I use the screen to display the voltage first. See the voltage. Display voltage for like 1 second. Let's jump to the manual. Do it again. See, it's 8.2 volts. So once it goes to manual, okay, I click this button to enable manual. Okay, so I have speed, SPD. So I use the right wheel, scroll right wheel down to change the options, because I have encoder can keep track of the angle I turn. So use the left side wheel as if like scroll down, it goes to the sub level. The key goes scroll down, it's going to be a sub level, which is the value for this moving speed. So use the right wheel to change the value, and scroll up to go back to the previous level, and keep on. So once I'm done with everything, I click this button, then use the sensor trigger to make a move. So that's what you guys should do. Because this screen can display a lot of things.
Yeah, and so this function is not like that helpful because it only displays characters. Like he was showing, 8.2 volts and stuff. Like it takes a little bit more like advanced function to do that because you have to like print a number. So we do have other functions that you can use, like display float and stuff like that. So you just have to like look into the code and you'll find those in there. We just did put it up here. Yeah.
Is short beat blocking?
Yes. Oh wait, no, it isn't.
No, it's running
Yeah, it's not.
It's running in a row.
Yeah, lastly, lastly, each of your kit mouse has 11 LEDs. To turn them on, for example, in your main function, all you have to do is write LED 1 on, and then you'll turn off your mouse. So very self-explanatory. You want to turn off? There's type LED 1 off in your main function.
So delay, this is an important function you're going to use a lot. Delay milliseconds, end time, it's milliseconds. So it's pretty self-explanatory. It doesn't block. It does block.
Yeah.
The other one, we do have another one which we didn't write on here. It's called elapsed micros, and that one doesn't block.
It doesn't block for the interrupt. It does block for the coding of values, but it does not block the interrupt because it's using the minutes.
Right. Yeah.
It will never get blocked.
Yes. Because so basically,
depends where you use it.
I'll get to the interrupt thing. I think that's here. So we have this interrupt called systic, which it's basically what an interrupt is it's basically when your code is executing, and then something will happen called an interrupt, and basically what that is means it stops executing whatever code it's currently doing, jumps into some other code, does that, and then jumps back to where it was. So that's an interrupt. And one of the main ones we're going to use is called systic, which is a 1 millisecond timed interrupt. So every 1 millisecond, no matter what code your mouse is currently running, it's going to jump into this function systic. And what Green was saying was you can't use delay inside this because delay actually uses this interrupt. So like this happens every 1 millisecond, so the delay actually counts it from that however many times this gets run. So you can't actually use a delay inside of it.
You can delay microseconds inside.
You can delay microseconds, yes.
It's short enough.
And so we also have two other interrupts, the button 1 interrupt and the button 2 interrupt. That's these two buttons. I don't know which one's which.
The right one is the button 0, the left one is button 1. So 0 is 1.
Yeah, I'm not sure which one we named which, but so yeah, when you press a button, it just stops doing whatever code it's doing and jumps into this function. So to control the motors, you also have set left PWM and set right PWM. It's a number from -999 through +999. That's your speed. So yeah, anyone not know what PWM is?
You should all know this because they're
Why is it a 32-bit integer?
It doesn't need to be, but it's just the microcontroller is a 32-bit microcontroller, so it's actually most efficient to use 32 bits.
You could use fast types.
Fast types?
Yeah.
I'm sure.
Like fast _int8_t, which would be an int 32, but it's platform dependent.
Okay. Yeah, I don't know. I mean, it doesn't matter that much. Like this thing has plenty of memory usually, so it's fine to use like a bigger value. You're also going to use printf a lot. So printf, if you never used C before, that's kind of like what is it called in cout in C++? It's like the same thing. Except it's not the same thing. It's got a totally different format. But basically the way it works is you can put these little percent and then a letter. In this case, D means decimal. So you could write like %f for float or something like that. And then
C for character.
or C for
percentage for
character.
hexadecimal.
Yeah. So you can put like as many of these like percent characters wherever you want in the string, and then you just have to have the same number of arguments afterwards. So if you have like 3% Ds, then you gotta have 3 arguments that are decimal integers, and then it just like puts it in. It just like puts this value into that string. And then yeah, you can find more info on this link. And then so the way that you actually, when you print something, you have to like read it somehow. So we use putty to do that. And you might be familiar with putty. You can download it here. You're gonna use like these options basically. We just write like what settings you should set. So you need to use serial mode. And then your COM port. So okay, let me like this. Or actually, I need to put that one. So I'm going to show you guys how to find the COM port. So you go to Control Panel. Device Manager. Ports. You can see this COM port 35. So it's the only one here, so we know that that's the COM port that we need to use. So here's putty. So what we would do is write COM 35 right here. And then
this is like baud rate.
Yeah.
So set that to 9,600. That means bits per second.
You can. That's like just the value that we use for the software. You're free to like increase it, but you got to change it on here and in the code.
They have to match each other.
So for now, to keep it simple, just put it 9,600, and you can ask us questions about
Yeah.
that. And there's some further instructions about how to set.
Yeah, you have to like set these different options, but we can help you with that if you have trouble. And then, so the way that you connect this is a different chip than what we were using to program. This is the programmer, but this one's the FTDI board, and that's how you communicate with the mouse through putty. So what you have to do is you have to look at there's 3 pins that you have to use again. It's TX, RX, and ground, except that TX doesn't connect to TX. TX connects to RX. So the TX of this thing is connecting to the RX of this thing. So it's like the transfer and then the receiving. So it's like when on the wire that this thing is transferring on, the other one has to receive on that wire. And then yeah, that's pretty much it. Then you can communicate with your mouse, and you can even send characters and stuff back to the mouse if you need to. Yeah, that's it.
Any questions?
Wait, did you guys use like a Bluetooth transmitter on it?
Yeah.
Did you interface it?
It's pretty much the same thing as this. It's pretty much the same way as using this. You just use putty, except your COM port's gonna be different because you're gonna have a Bluetooth adapter. So you just gotta check what the COM port of your Bluetooth adapter is.
Any other questions? All right, so we're going to distribute the mouse to all of you guys and have a practice on those code. All right, that's so much for the lecture 1. Thanks for coming.
I need to install the